Hi there, welcome to Nine Lean. Um, this is the second screencast on binary search trees. So, I hope you enjoyed and learned about how to create a binary search tree in a pretty simple way with a very less code base. Uh, so, this code is small, but it's exactly a lean code because the tree data structure and all the accessory functions are actually dependent upon the type of the node, which is integer. And if you require a user defined type or a different built-in type, you need to write the code again, which is not a good idea. In fact, it's a very bad idea. So uh, just bear with me. I'll just explain how you can convert this into a lean code or multi-purpose lean code. Remember, lean code is something which I had explained in my site at 9lean.com, is that a small footprint which can achieve most of the things. So especially in C++, there is something called template, which is very good for whatever magic you want to get it done, and it does everything in compile time, and that's the beauty of it. I suppose you are somehow familiar with the syntax of template. You don't need to know all the things, but it's actually very simple as compared to whatever most people think. So let's create this a generic type. So create a generic type by saying type name type, convert this to a type, correct? So whenever whatever you pass, it can be that. Now we have all these helper functions. These functions also needs to be templated. There are two ways. Either we do template type name type for each of the functions, or wrap these functions in a class called tree helper, and end of class tree helper, and there it is. So you make sure these are public so that you can call them. That's all. Now you have to change type to wherever you are taking. Sorry, what is happening? Copy type to wherever you are taking int, type into type into type. Oh, looks like this class is left out. Right. Now if you go to the class over here, this make node is a member of this class now. So we first need to create an instance of tree helper. Thank you. Tree help, and it's a templated class, so you have to, let's use int for the sample. Tree helper id makes things fast. And tree also I want to create for the int. My tree equal to, now it's a part of tree helper dot make node is. Thanks. Here you go. So insert is also member, will have this inserted for all of them. I'm just doing a copy paste for sample. Actual implementation you can do it in much better way, loops and other things. It's up to you. Now over no. So since we are taking, look at the way we are actually instantiating it. We are qualifying it with a template parameter. Here also, wherever we are using tree, it has to be qualified with a template parameter. So you can see template type equal to new tree of type. Maybe you can do that. Not necessarily. Here also, wherever you in the functions you are taking tree, you have to take templated tree. Here also you have to take templated tree set left. So here also we'll do templated tree, and same over here also. Okay, so if you say int, everything will be replaced by int, and That's pretty much it. I hope it compiles. Let me compile. Success. And if I run this, the result should be ascending order. Yep, 0, 12, 13. Now since int can be represented by float also, so let's do it for float and float. Now let's compile it. Success. Run it. Fine. So here you see we have just added, I think 2, 3, 4 lines of code and added the tree into a templated tree. Okay, that's very good. We can do some more improvement, like these functions are not called from outside, so we can very well make it private. Here we go, and compile everything. Success. Hope so. What? Yes, success. Now this is for built-in types. Now let's see for user defined type. Let me have a user defined type, and for the simplicity purpose I'll just have a user defined type as integer, and I'll just make it public so that it access is fine. I'll have a value as int val. You can have any user defined type. Okay, and now see what will happen if I build a float replace with a user defined type. Okay, first of all, this you cannot give number. We have to create a user defined type called maybe u type, and I'll say u type dot val equal to 65, and instead here I'll give just u type. Wherever I'm giving 60, I'll give u type. Oh, sorry. Here I'll change it u type dot val equal to 23, and okay, let me change it, then I'll continue. So I have changed the val as the numbers and inserted u type. See, I understand this is a bit uglier, but live with it. You can just for testing purpose. You can do it in any way. You might be thinking that is done. We create a user defined type and it will take a user defined type, but well, try to do some. Let's try to compile it and see what happens. Errors. Now template errors are actually very difficult to understand, but I'll tell you one thing. This comparison cannot happen. Okay, these kind of comparison on user defined type, you will have to do two things, or one of the two things. Let's say maybe I'll create a function called less than, greater, less, no, what is this? This is less than or equal, and I take integer at as a right hand side parameter, and I'll return this dot val is less than equal to RHS dot val. Done. Okay, and of course you cannot in the intrive you cannot print it, so I'll just hold it for a while. Print function, I'm not printing it. So here if you do this, what is happening, I can replace this particular if condition with something like this: val dot, no, cannot do that. So type it in a val, then less than or should be able to less than or equal to a3 dot val. It should work. Let me compile it for a while and see if it works. Yes, it works. Okay, now fine. But let's say if you create a tree helper of user defined type, again you'd want to create a tree helper for built-in types. Int t help 1 equal to new int. Fine, everything is fine, but if you compile it, let's see what happens. It will give error. Okay, yes, it will not give error still. I am sorry about that. I'll have to create this and call this function. Let's say t1 equal to t help dot make node 100, and let's say t helper dot insert. Now this is the problem start. Let's say t1 dot 200. Sorry, this is t help 1. Now if you compile it, see less than and equal to. If you create a function called less than or equal to, it is these kind of functions is not there in the built-in types. So what do? Shall we have two code for built-in type as well as for user-defined type? That will be a stupid idea. For that reason, there is something called operator overloading given by C++. The same less than and equal to function can be removed by something like this. Bool operator less than equal to, everything will be same. Integer right hand side and will be return again this dot is less than equal to RHS dot val. Done. And is here you just remove it for val is less than equal to val. Okay, now compile it. Success. See, so it now worked for user defined type, which is integer, as well as for built-in type, which is int. So when I'm writing it again, I can just uncomment it. So see, basically this user defined type will be defined by user, but basically without changing much of the code, it's still the simple binary search tree, and it helps a lot. I mean, it's a very simple, it's working, and there is no change in logic as compared to what we did in the first video. The logic is same. We have just added a template type to make it a bit generic. So that's pretty much it. Similarly for printing, actually either you have to directly, if you want to directly print, you will have to overload this operator, or you can write a generic print function, or you can do whatever is best suited for your code. So guys, that's pretty much it. In the next video we'll see doing the same thing in Java. Thanks a lot for watching. Do share it if you like it. You can give some comment also. Thanks a lot. Have a good day. Bye.